Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, Dr. Shukri. My name is Muhammad Al-Jabu. This is the video required for assignment 1 on behalf of myself and my group mate Helen. So we will begin by talking about the first program, which is the wheel speed measurement. In the beginning, we'll look at the code. Starting here, we see that there's a comment section describing how the program works, and then we move on to define some constants, then some global variables for use in the code. Then we define the interrupt service routine for encoder 1 and encoder 2. These two codes for the encoders are identical except for the variable names being used. Then we move on to the setup. The setup function starts by configuring the pin modes for the encoder inputs and then configuring or attaching the interrupts to the signal A of each encoder. And then it moves on to initialize the serial port and print a greeting message. And then a small delay is executed before beginning the loop. This delay is because we found that when running the code, initially the calculation produces invalid values of RPM for encoder 1 and encoder 2, and then the values stabilize after a second or so. So we just use a 2-second delay before starting the loop, which prints the calculated RPM values and just has its own delay to improve the simulation speed. Next, we move to the circuit diagram. We have, as expected, the ESP32. We have the encoder emulation circuits for encoder 1 at the top and encoder 2 at the bottom with the clock sources and the logic gates. Then if we start our simulation, see that it prints the greeting message as expected and then prints the RPM calculated from encoder 1 and encoder 2. And as we calculated in the assignment report, we expect to have 60 and 120 RPM. And then if we resume, we can change the direction. We can see the sign of the RPM value change as well for encoder 1 and then for encoder 2. And that's about it for this program. Next, we move to the DC motor control program, where we have same description of the program itself. And then we define some constants. And then after that, we define some variables, declare some variables to store our data in, our input and output data in. The first two variables are to store the potentiometer inputs, and then the second or the third one is a customized data type, which is in the form of a structure that stores 1 integer and 2 Boolean values. This is used to store all the data for each motor driver or each motor in the motor driver, where you have a duty cycle and the Boolean value for the direction control pins. Next, we have a custom function called pot to motor driver, which takes in an integer potentiometer reading analog input as an argument, and then it returns the custom data type for a motor driver. So first begins by declaring the output variable, the output structure, and then it checks the input, where the input is within the range of 0 to 4095. And then based on that input, it decides the duty cycle and the Boolean values for the direction control pins. And then finally, after all the values are determined, it returns the output. Next, we move to the setup function. We start by configuring the PWM channels, frequency and resolution, then attaching the pin to that channel. And then next we set the digital input and output pins appropriately. And then we initialize the serial port and print a greeting message. In the loop function, we start by reading both potentiometer inputs and storing them in variables. And then next we move to, excuse me, we move to calculating the outputs based on the potentiometer inputs and using the custom defined function pot to motor driver, and then passing the potentiometer 1 and potentiometer 2 inputs. And then after that, once all the values are calculated, we just simply pass those values to the output pins. We start by the PWM and then the 2 direction pins, and we do the same for the second motor driver. Finally, before the end of the loop, we just print the calculated duty cycle values to the output, to the serial terminal. And then there's a quarter-second delay to improve the simulation speed. Look at the circuit next. Then we have ESP32. We have the 2 slide potentiometers, and on the left-hand side, and then on the right side of the ESP32, we have at the top the motor driver and motor emulation circuit for motor 1, and at the bottom for motor 2. And when we start the simulation, we see that immediately prints the greeting message, and then it starts printing the duty cycle values, and we can control each motor individually using its slide potentiometer. That's motor 1. Now we do motor 2, and it works. And if we look at the serial plotter, we can see that the PWM, the duty cycle drops at the center and reaches maximum at the extreme ends of the slide potentiometer. Same for motor 2, drops to 0 and then goes back up. And this gives us confidence that this code will work with a real motor driver and motor. That's it. Thank you very much for your time. I hope I was able to explain everything there is about these 2 programs. Thank you. Assalamu alaikum.